We have proven a central limit theorem, which was, let's say, a random variable Zn equal to summation of x1 plus x2 plus etc. xn divided by a square root of, let's say, n. And we said that if these random variables are independent and they have identical distribution, then these will become normal with some mean and some variances. And we said, oh, you have to deduce the mean. So those conditions, they could be relaxed, and we don't need them to be exactly independent. But instead of exact independence, we could have weaker conditions, or we don't need them to have identical distribution, so on. And yet the sum or the weighted sum will converge to a normal distribution. In general, when you do lots of relatively independent random variables, when you add them together, the distribution of sum will tend to have a distribution which is similar to Gaussian distribution. This similarity increases as the number of components increases. So the central limit theorem in its original format has some restrictive condition, and in this video we talk verbally about some of the generalization which has been done. There may be lots of other generalization in the literature, and you can look at them. So so the constraints on this theorem is that they are independent and they have to identical distribution, and they have finite variances. So these three constraints, sometimes they are restrictive. So as a result, we can lose some of these restrictions. For example, we could say if they have arbitrary independent distribution, so central limit theorem is proven. The proof is very similar to what we have done. Or we could say they are asymptotically independent. We don't need them to be independent, we need them to be asymptotically. That means that their dependencies, if you take two samples, f of x of n and x of m, two samples, let's say x1 and let's say x of n and x of m, then these could be approximately written as the marginal distribution, okay? And this approximation means that limit of this one, when both n and m, they are large, this will become like product. And so on. So there are some other extensions that you can find in the literature and use. And this concludes this chapter.